Now we're recording. Okay, so basically what I'd just like to say about the test, this was definitely the toughest test. If you're in the A and the B category, I'm not talking to you. If you're in the C through the E category, here's what I would like to say. I know, and probably I'm not talking to anybody who's currently listening. Hopefully I'm talking to the people who are not here that are going to watch the recording later. I know that learning online is very difficult. If you want to be successful, here's my advice. You need to come and be able to ask questions and be very engaged during our regular class time. Make sure you're doing your homework. You know, I'm no longer, I've got the quizzes online. Technically, you don't need to come to class anymore, but I think you can see for those of you who didn't come to class, that's why these scores have dropped so dramatically. Normally, this doesn't happen. This is fairly easy stuff, but I know it's hard if you're not doing your homework. I mean, it was clear to me that I know on this last test I asked you to do a problem a certain way, and if you didn't do it that way because you weren't familiar with it, that to me says you haven't been doing enough homework. So anyway, I would just like to encourage everybody to keep coming to class where you can ask questions and interrupt me if you don't understand anything, and that's really going to help. So the way our next test is scheduled for about 3 weeks, in about 3 weeks, basically. The last week of class I have devoted, I would like to make it a review of the final exam. And so we've built that in, and I want you to all to do really well. The final exams are really hard. It's written by the department, not by me. I haven't decided how we'll do it. We'll probably use the reviews that I've already posted. Of course, I'll have another review. I may, I'll probably try to do some sample tests. I've in the past worked at Salt Lake Community College. They have a mix of multiple choice and show your work. I can show you some of their final exams to kind of get you ready. Of course, UVU has a rule of no multiple choice on the final exam, so it'll be different in that respect. But hopefully it'll be a good way to prepare everybody for that. So let's go ahead. I think I want to open up a new thing. I'm going to go ahead and close that. I didn't make any changes. Okay, so we're going to start on 7.3, which is hyperbolas. I do want to show you a couple of animations. So the idea with a hyperbola, you can see there are these two curves. The focus is kind of on the outside rather than on the inside, if this was your axis. It consists of two planes on with a fixed constant. I've got some other, this is an example of basically if you take a straight line and you rotate it around, this becomes a hyperboloid, basically a hyperbola of revolution. If you've ever seen a nuclear plant cooling tower, they are in the shape of a hyperboloid. I don't really know why that is, other than obviously they have a lot of mathematicians that think that that must be the best way to cool very hot nuclear power. Oh, I'm missing one of my things here. By the way, I guess good headline, New York shows signs of hitting the apex. So that's hopefully a good thing. Let me show you, I've got one more. Oh, it's right here. I wanted to show you, just to prove to you that you can use a straight line to make a hyperbola. This is an animation. You can see the hyperbola here, and that the straight line passes directly through that curve. So that's kind of interesting little animation there. So that's basically a hyperbola. All right, so Now, the general form of a hyperbola is basically we've got two forms here. One of them is going to be x squared over a squared. Maybe I should move these over. And I'm going to underline that so it looks like a fraction. Minus rather than plus, you know, in, whoops. With an ellipse, you have a plus. With a hyperbola, it's a minus. Y squared over b squared. Underline that so it looks like a fraction. And that equals 1. You could also have, here I'm going to copy this. You could also have the y be the first variable. So y squared over a squared minus x squared over b squared equals 1. Now, so the thing that I want to point out is the first variable we talked about is what we call the transverse axis. You could also think of it as the major axis. That's what we call it in an ellipse. We'd call it the major axis, but in the hyperbola, we call it the transverse axis. So the vertices are basically at plus or minus a comma 0. And if in the case where over here, maybe I'll do it this way, vertices, it's going to be 0 plus or minus a. Okay. So basically, you're just going to flip the points, basically, depending on if the y is first versus the x. You've got asymptotes in this case. And the way I think I'll write that as is basically y is going to equal plus or minus bx divided by a. And in the case where we've got the y first, we're going to switch the a and the b, and it's going to be plus or minus a over b. Okay? So you're just going to flip those. You've got foci. The foci, if your x is first, is going to be plus or minus c comma 0. And of course, over here, your foci will be 0 plus or minus c. So remember, the foci are always on the transverse axis or the major axis. You can think of it the same way. Okay. Now let's talk a little bit about the graph. What I think I'm going to do here, I'm going to copy both of these. Hopefully this will copy. Fairly well. Okay, so basically, if I'm doing the graph on the left, okay. So the way this is going to work is, since x is first, I'm going to go out x units, or a units in the x direction. So this value here is going to be a units. And in the minor axis direction, although we don't really call it a minor axis, you're going to go b units in this direction. So this would be b. Okay. And the basic way to draw this is, what I'm going to do is I'm going to draw a box that goes through b and a. Okay. And then the idea here is, excuse me, I need to get a drink. Your asymptotes are going to go, whoops. Your asymptotes are going to go through the corners and through the origin. Okay, and then we're going to have a curve that goes like this through A. That's supposed to be through A. Sorry, it's off a little bit. And it'll look like that. Now, in the case where you've got it on the right here, I'll draw my axes again. Now we're going to go, this will be your A units here. So that's your A units in the Y direction. And then you've got your B units in the X direction. So this is your B. Okay. Then I'm going to draw my box. I'll draw my asymptotes through the corners. But of course, since the Y is first, now my hyperbola is going to go through the top and bottom, just like that. Okay? Does that make sense? Does anybody have any questions with regards to that? Okay. Well, let's go ahead and we're going to do a problem. Okay. Let's say that I want to say that a hyperbola has the equation squared minus y squared. Oh, actually, no, let me back up. 9x squared. 9x squared minus 16y squared equals 144. Okay? So if this is the case, let's say that we want to find the foci, the vertices, the transverse axis, and graph. Okay? So, God, we do not have very many people here. This is why this class didn't do so well. But all of you who are here are going to do awesome, so I'm excited for that. So let's pick on Danae. Danae, can you help me on this parabola?
Sure.
Where do you think we would start on this?
So would your 9x squared be your A?
Well, remember, when we did these before, it always equaled 1. And this does not equal 1. So how could we make it equal 1?
Minus 144 from each side.
We could do that, but I don't want to. I want it to equal 1, not 0. So rather than do that, how about if we divided by 144?
Okay.
Does that make sense? Okay.
Yeah.
So if I divide by 144, now the nice thing about this is this book does try to be nice to you because 9 goes into 144 a whole number of times. And if you were to guess, what do you think it would go into?
16.
Exactly. So it's going to be x squared over 16 minus y squared over, what do you think?
9.
Perfect. And that's going to equal 1, okay? And I'll underline those so they look like fractions. Okay. All right, so now let's talk about the transverse axis. What do you think? Don't need that to be underlined. Is the transverse axis going to be the x-axis or the y-axis?
The x-axis.
x-axis because
It's the first variable.
it's the first variable, okay? And let's talk about what does A equal, what does B equal, what does C equal? Do we know any of those?
A equals 4, B equals 9.
B doesn't equal 9, it equals 3.
Yeah.
Right? Square, okay? And then, oh, you know what? I just realized I forgot to give you one more piece of information. Let me go back here to my Excel. We didn't tell how you C equals. So A squared plus B squared equals C squared, okay? And that works either way, okay? Now, just as a reminder, the difference between a hyperbola and an ellipse is that instead of a minus, I have a plus here, okay? Now, if you'll remember, as far as finding C, we always said C squared equals the big number squared minus the small number squared, okay? Now you could think of this as A squared minus B squared if A is always the big number, although we didn't always do that with the ellipse. But just think of it this way. If you have a plus in your main equation, this becomes a minus. And if you have a minus in this equation, this becomes a plus. Okay? So remember, they're just kind of flipped. Okay? So let's go back to our problem here. We need to find C, and since Danae did so awesome, I'm going to pick on Andrew. Andrew, can you help me find C?
Okay, so would it be 16 squared minus n squared equals C squared?
Well, 4 squared and 3 squared instead of 16 squared. So 16,
Oh,
C
yeah.
squared equals 16 plus 9 in this case,
Okay.
which we're very lucky equals 25, right?
Mm-hmm.
So we got very lucky. So C is going to equal, in this case, 5. Okay? So, oh, I didn't know I drew a pink line there. That's kind of weird. I don't know how that happened. It's still got black selected. Okay, so as we draw this, I'm going to put tick marks here. 1, 2, 3, 4, 5. I'm going to copy that because I don't want to keep redrawing them. And I'm going to put that right here. And then I'm going to draw 1, 2, 3, 4, 5. I'm going to copy that. And hopefully put that about right there. Okay. So since Andrew helped me with that, okay, so C equals 5. Okay. So let's pick on Riley. Riley, can you help me draw this hyperbola?
So do you put the vertices first?
Okay, where are the vertices?
Plus or minus 4, 0.
Plus and minus 4, 0. Okay, so that's on the x-axis, right?
Yeah.
Okay. So I've got those. What else do I want to draw next?
The foci.
The foci, where are the foci? Oops, I didn't mean to do that. Put that back.
Plus or minus 5, 0.
That's correct. Okay. So I'm going to try to draw those in red. So those are going to be right here and right here. Okay. What else do I need?
The asymptote.
Okay, how do I get that?
y equals plus or minus 3 x over 4.
Okay, so your asymptote is y. No, don't forget, it's always got to be y equals
Yeah.
plus or minus. Say that again. What did you say?
3x over 4.
3x over 4. Okay. Now, how would I draw that on the graph?
I'm not really sure.
Okay. Who can help him out? It must be Hallie's turn. What do you think, Hallie?
Oh, sorry, I was on mute.
Okay.
I'm not quite sure. Would you go like up 3 over 4?
Well, so you'll just go up and down 3 on the y-axis. Okay. So I'll put those back in black. I'll try to draw these here. So that we've got, oh, I drew it in white. How did I draw it in white? I picked black. Oh, now it's black. I'm on the phone, bud. And then right here. Okay, so now what's next?
Oh, so you just plotted the b vertices, so now you have to plot the asymptote. Is that what you're asking?
Yeah, so how do we plot the asymptote?
I don't know. Would you go, is this where you go up 3 over 4?
So we're going to draw our box now.
Okay.
Okay. So we'll draw our box here. So the box is going to be all the block. Oh, I didn't mean to draw circles. Let's draw lines. You know what? I'm going to do it with the pencil. Question, go ahead.
So then if you're going to draw the asymptote, don't you just make those the corners?
Yeah, so that's why the box is helpful, so you can see where the corners are. And now you can draw the asymptotes here. And now, since this is the vertex, I'm going to draw just like that. Okay. So there's your hyperbola. Okay, so we found our foci. Oh, let's be super clear on the foci. What are the coordinates for the foci?
Plus or minus 5, 0.
Plus or minus 5, 0. Oops. And your vertices are where?
Plus or minus 4, 0, and then 0, plus or minus 3.
So we'll go ahead and leave off those because the plus or minus 0, 3, it's not actually part of the parabola. That's just to help us to draw the asymptotes.
Okay.
So, okay. And our transverse axis, oh, I already wrote that. That's the x-axis, and we've graphed it. So there you have it. Okay, piece of cake. You guys gonna ace my quiz tomorrow?
Yep.
Okay, that's good. All right, so maybe I will save this and we'll do another problem. Okay, except for I walked upstairs and I left my books downstairs. Just let me grab my book here, just 1 second. All right, so now, in this case, let's say that I want to find the equation of a hyperbola. Here, I'm going to create a new sheet here. the equation of a hyperbola with vertices at minus 3, 0 and foci at plus or minus 4, 0. And sketch the graph. Okay, so how would I go about doing this? Okay. Turn is it now? It must be Lauren's turn. Where would you start on this one?
Could you start with the vertices at positive and negative 3, 0?
Okay, so those are on the x-axis. Let's draw our little tick marks. 2, 3, 1, 2, 3. Oh, that was terrible. Okay. All right, so the vertices are going to be right here. Then what?
You could also plot your foci.
Okay. The foci are where?
Positive and negative 4 and 0.
Okay. So those two things there. The only reason I'm putting these in a different color is just to distinguish them a little bit. Circle. Okay, so that's my foci. Okay. So do we know what our A, B, or C equals?
Well, either our A or our B would be the plus or minus 3, 0.
Okay, so how do we know if it's A or B?
Oh, because it's on the same line as the foci?
Correct. So our basic form of our equation is going to be x squared over a squared. Well, actually, is it going to be x first or is it going to be y?
X first.
X first because?
Because the vertice is on the x-axis.
That's correct. That's correct. Okay. All right, so x squared over a squared, and is it plus or minus?
Minus.
Minus y squared over b squared.
Why is it minus?
Who knows the answer to that question?
Because it's a hyperbola.
It's a hyperbola. Okay. Hyperbolas are always going to be minus. That's the basic form, right? Okay.
Oh, sorry.
All right. So now, did we decide that we knew A or B?
A is 3.
A is 3. Okay. So I can actually, let's go ahead and let's get rid of this A squared. This A squared is going to be what?
3 squared.
3 squared, which is 9. And then do we know B or C?
We know C.
We know C. C is
4.
4. Okay. And so how would we find B?
C squared minus A squared.
C squared, A squared plus B squared, right? So if we solve that, that's going to be 16 equals 9 plus B squared. And therefore, B is going to equal the square root of 7, right? Does that make sense?
Yeah.
Okay. All right. So if B is the square root of 7, so the square root of 7 squared is what?
Seven.
It'd be 7. Okay, so in this case, this number here is 7. Okay. Now let's think about it. The square root of 7. So 4 squared, or 2 squared, no. 2 squared is 4, 3 squared is 9. So it's going to be up and down. Let's go back to black. Between 2 and 3. So 1, 2, 3, 1, 2, 3. And so as I'm drawing my line, it's going to be in between 2 and 3. Whoops. Let's go back to the pencil. I thought I was going to the pencil. Well, that's terrible. Anyway, hopefully you get the idea. Then I'm going to draw my asymptotes through the origin and the center. Pretend that's through the origin. And then I will finish drawing my hyperbola this way. Okay. All right, so we've got our equation right here. Okay, does that make sense?
Yeah, question.
Okay, go ahead.
Because it's a minus, is that why the hyperbolas are going out and they're not connecting in the equation?
Basically, yeah.
Okay.
Okay, any other questions? Okay. All right, well, let's do one more here. This will hopefully be a little bit harder. Let's say that I want to find the equation. Here, let's pick a different color. Blue. Find the equation of and foci of the hyperbola with vertices at 0 plus or minus 2 and asymptotes at y equals plus or minus 2x. Okay. All right, so if I've got my axis here, who else do I have left? I think I've called on everybody. How about Michael? Oh, you've already, well, we'll just pick on you, Michael, just because. How would you start on this one?
Well, you know A, which is 2. So y squared over A
Okay.
minus, and you have the asymptote, and you know the asymptote equation has to be y equals ax over b, and since it's plus or minus 2x, b equals 1.
You're going way too fast for me to keep up.
Okay.
So y equals b. Is it a over b or b over a?
It is a over b,
Why is it a over b?
because y is the major axis, the transverse axis is on the y-axis.
Good answer. Okay, so let's draw. So we're going up and down this time rather than left and right. So we've gone up 2, down 2. And this is my, oops, transverse axis here, or the major axis, okay? So we know, in fact, I'm going to draw this now because a lot of times, sometimes when I draw these, I get mixed up with the focus. So I always like to draw those right off the bat. Okay. So the y is going to be first this time.
Mhm.
So it's going to be y squared over a squared minus x squared over b squared equals 1. And of course, we'll underline these so they look like fractions. Okay. All right. So now, and actually we did know that a squared is actually going to be 4. So I can actually change this to a 4 right off the bat. Okay. So we're almost there with the equation. If a is 2, and I think you said this before, but I couldn't keep up. What is b?
B should be 1.
1. Because we know that our asymptote equation is going to be 2 over 1. Okay? And therefore, what does c squared equal?
A squared plus B squared, or 4 plus 1.
B squared. Okay? Which equals 4 plus 1. So therefore, c is going to equal the square root of 5. Okay? Can we put that up there, I guess? All right. So the square root of 5 is a little more than 4. So if I were to draw these here, I'll draw these in red so that we know it's the focus. The focus is going to be, if that's 3, positive 3 and negative 3, your focus is going to be just a little bit, oops. It's going to be just a little bit more here and here. Okay. All right. And then, so we go right and left just 1, right? So 1, I forgot my thing here. 1 and 1. And so when I draw my box, it's going to be a kind of a small looking box. And then I'll draw my asymptotes through there. Okay, so I did pretty good. Okay, and so the last thing I need to do is just fix my equation. So we get rid of the b squared, and the b squared is now what?
One.
1. Okay, and there you have it. There's your equation. Okay. So I think we're out of time, but that's basically 7.3 hyperbolas. So your quiz is already up. So we will see you all tomorrow.
Thank
Any
you.
last questions before I let you go? Okay. Well, good luck with the homework, and we'll see you all tomorrow.